Hello, I'm going to show you how to use NavMesh2D in your project. Um, it's available on the Asset Store and I'll provide a link for it in the video description. So in this project, it's an empty Unity project, 2D default project. I've imported our NavMesh2D into this project. So first thing you'll see is the Pigeon Coop Toolkit folder. Inside there you've got your NavMesh2D examples folder. So click into that. You can read the documentation here. It's basically like a short walkthrough guide and it covers a lot of good stuff, so they're worth reading. I'm going to try and cover most of the stuff talked about in there in this video. Alright, so we're going to quickly prototype a scene and get the NavMesh working. Okay. In the prefab folder, I've provided you some building blocks and you can use these to prototype your scenes. Okay, you got a floor, a polygon, circle, and a box collider. Position these however we want. Now, just scale these up a little bit, move them around, get something that looks alright, I guess. So now once you've done that, you've got to put your walls and floors onto separate layers. Okay, so in our layers, drop down, add a layer, specify a wall and a floor layer. Okay, now each of our colliders need to be put onto their respective layers. So the walls will be on the wall layers and the floor can go on the floor layer. Now a handy tip is your floors will need a collider on them, right? And that's sort of, Unity doesn't like it when your rigid bodies go through colliders. Okay, so it's a good thing to put your floor colliders as triggers. That will allow your rigid bodies to actually move through the floors. Okay, that's just a handy tip for you. But you will need colliders on the floors, so just keep that in mind. You can also disable the collider if you want to, and as long as they're tagged as floor or whatever layer you've chosen for the floors or walls, they'll still get processed. Okay, we're going to leave it as trigger. So once you've done all that, go to Window, Pigeon Coop Toolkit, and NavMesh2D generator. Okay, so we're going to dock this over here. Now, these are all the default settings. We'll walk through what some of them do, but most of the default settings should be fine for your first scene. So specify the wall and floor layers. Okay, sorry, it's the other way around. Your walkable layer should have the floor, your obstruction layer should have the wall layers. Okay, now once you've done that, hit bake. Okay, and you'll see your NavMesh on your scene already. Okay, that's all there is to it. The NavMesh is there and good to go. Okay, up here you can see some customization options for what you can see. You've got a toggle for the NavMesh itself. You can have a look at the wire. Okay, and you've got a path tester as well, and this actually tests your path. This will be the path returned by the NavMesh during runtime, so it's very handy to see how your NavMesh is going to function in game. And this is also good for finding problems too. Okay, so for example here, you can see that rather than going sort of straight along, it wants to go to this point and then down. You'll get a lot of problems like this when you generate a NavMesh that's very sparse in detail. Okay, and I'll teach you how to fix this as well. Now, to add more detail into your NavMesh, you can bake a grid into the NavMesh itself. Now we're going to bake a grid, and the grid will be 0.5 by 0.5 in size. So hit bake, and you can see how there's now a grid baked into your NavMesh itself, and this just adds more nav nodes, like points of navigation for the algorithm to find a better path. It's A#, so it needs these nodes to find a better path. Okay, and it obviously means it's a little bit slower. Oops. And it obviously means it's a little bit slower, but the results are better. So it's up to you to find that balance. There's no right or wrong answer. It's just whatever works for a project. Okay. Some of the general settings. You got your circle subdivision factor. This is a value that tells NavMesh how much it should subdivide circles by. It's a scale value. The subdivision factor is relative to how big the circle is, right? So for example, if we make this a bigger value, say 0.8, we have a very coarse outline for our circle, okay? But if we have a bigger circle and we hit bake, we have an outline that's just as coarse as before, but the segment lengths are the same, okay? So this is really nice for keeping your NavMesh uniformal. So you can see how segments are the same length, okay? And this goes for, you know, finer subdivisions as well. So if you put it on 0.2, you get really small subdivisions along small circles and large circles. So it's the same nice edges, regardless of the size of the circle, okay? Your float precision is not very important. You won't really be touching it. It's how many floating points, how much floating point accuracy there is. So if 2 is the accuracy of floating points will be to 2 spaces, and this is not really that important. But if you are making a game where the main character, like the characters are really tiny, like 0.01 in radius or something, you might want a finer floating point precision. Okay, if you're making a really big map, and you want a larger NavMesh, then you might use less precision at the cost of, you know, jagged edges. But that might be okay for you, right? It's just a matter of finding something that works in your case. Your padding is how much padding to add between the collider and the NavMesh itself. Okay, so we can increase it. More padding, less padding, no padding. It's up to you. You can do whatever you like. Now you've got your joint types. We'll put this back to 0.2 or something. Now you got your joint types as well: square, round, and meter. You'll mostly be using square and meter. Meter is just, you know, your sharp corner. There's nothing special about it. Just straight down, straight across. This is normally going to be okay, but oops, it makes pathing around corners a little bit an issue. Sometimes you'll get, sometimes you'll get a nice result, sometimes you won't, like this. It's just because it doesn't have, again, not enough data around the corner for it to calculate a nice path. Instead of going from here to here, it's trying to find a path from here to here by going up and across. Square corners can fix that problem, and I always use square. Square is just the nicest. It's not too much extra data, but it's just enough. So when you square off edges, you'll get edges that are, well, they're squared off, and that makes cornering a lot easier for the framework as well. Okay. Your last one is round. Don't really use this one much. It adds a lot of extra points around corners. It's nice because it produces, this nice cornering. It'll produce nice cornering for your NavMesh agents, right? They'll come to the corner and they'll curve around it and it'll look nice and everything. But it comes at a cost. It adds more processing, and if you don't really need it, don't put it in. It's just there for some added flair if you really want something like that for your game. The last thing is baking grid. So you can bake a grid into your NavMesh itself. Or you can choose not to bake one. When you don't bake a grid into your NavMesh becomes a lot simpler. So processing wise, it's a lot easier to process. It generates really quickly, and the pathfinding algorithm won't take as long. But it comes at the cost, again, of paths that are not completely accurate. It just doesn't have enough data to go off. And again, it's just up to you to find a nice balance. There's no algorithm out there that can determine what's the best case scenario for your map. It's up to you to decide that. And they're the main options. I suppose the last thing is up here. You've got an option to change the color. So if you're having trouble seeing your NavMesh, you can actually adjust the color of the NavMesh itself and get a better view, especially for the wire itself. the Y is sometimes hard to see on certain colors, right? And changing it can really help. So if you had like a grass floor and your NavMesh was green, you couldn't see anything. You could just make it red and see everything really clearly. Those are the basics. It's pretty easy generating a NavMesh. Not much more to it. Okay. Now we do have a code snippet in the examples folder to help you navigate it. So we'll generate a bigger map like this. Okay, we'll bake a grid into it as well. And we'll just add some more obstacles in the way. Okay, that looks good. Now, navigating it is pretty easy. We've provided you a script. It's called path follower. Okay, it's a very simple script. We'll open it up and have a look. Let's give this a moment. Sorry. Okay. Make this a bit bigger for you guys. To get a path from NavMesh, all you need to do is call NavMesh2D get smoothed path, or alternatively just get path. Okay, and that gives you a path that's not been smoothed. So once you get a path, your path is just a list of vector 2 points. Okay, so it is very easy. So what we're doing in this example is we're getting a list of when the user presses the E, we get a path from our current position to our target position. Okay, so while the path is not equal to null and the path has some points in it, we move towards the current node in the path. Okay, once we're close enough to that node in the path, we remove it from the path. This is just this is how you navigate, an arbitrary list of vector 2 points. Okay, it's nothing special. This is all you need to really worry about. How you use the path, how you use that data is up to you. But this is just one way to navigate the path. Okay. So what you can do is you can create a cube, just so we have something to see. We'll make it a little bit smaller. So that's our cube. We'll add the script path follower to it. Okay. And we'll call it path follower. Now we'll create another cube. We'll call this one destination. And we'll attach the mover script onto it. The mover script just lets you move the object by pressing WASD. Okay, that's all it is. We'll position this somewhere as well. Just put it here. And now in the path follower, drag the destination object as the pathing target. Okay, and that's it. So now we press. We'll put the scene view over here as well, so we can see what's happening. Press play. So what you can do is you can move the pathing target with WASD. Okay, and press E to path to that target. Okay, that's all there is to it. You can use this code in your game as well, but this is not the only way to follow a path. For example, what you could do is you can get, when I press E, it'll get the path from here to here. And what I like doing is I like my agent raycasting a couple of nodes ahead to see if he can actually skip a few nodes. So if the path goes, from here to here to here to here, he may just be able to go straight from this point to that point. Okay, those are some of the kinks that the smoothing algorithm can't kink out. It just sort of has to go with, the flow at the level. But you might be able to avoid it depending on what you guys are doing, right? For example, if he's moving really, really fast and he overshoots the target, he'll be able to see that he could just move from, rather than going back to the previous point, he could just keep continuing along the path. Anyway, that's all there is to it, and I hope it helped out. It's very good for small projects. Very easy to get stuck into, very easy to use. I hope you enjoy using it. Thank you.